Let's look at convolutional math in a little bit more detail. As you saw earlier, human being looks at image and they can appreciate the aesthetics. But when computer looks at it, it is just an array of numbers, right? So here on the left side, you see a Pittsburgh skyline image as seen by human being. On the right side, it's the NumPy array, which is as seen by the computer, right? So a convolutional, as we just to recap, is an operation where we take a small matrix. We usually call it a kernel, and we convolve it over an original image. So by convolving, basically what we mean that we put the small kernel on top of our original image, covering the same area as the kernel, and then slide it and multiply each element of the original array with each element with the corresponding element in the kernel, and then multiply, just to multiply them and put the final number in the original matrix. We do that for the complete 3 by 3 matrix in the kernel, and then we perform that operation on the first 3 by 3 top left part of our matrix. Then we slide the image to the right. So this is the operation, convolution operation. You multiply and then you sum. So let's go step by step. So this is an output would look like. First you multiply them, all the elements, and then we add them together, and then the final sum will be 115. So a 3 by 3 part in the original matrix will be replaced by one number. That's what convolution does. So let's go step by step. So that's the operation that we did for first 3 by 3 part of our original matrix. Then we slide the kernel to the right, and then starting in the second column, we perform again the same operation for column number 1, 2, 3 and row number 0, 1, 2, right? You perform the exact same operation and then write the final output number. Then we again slide the matrix to the right and perform the same operation on the top right part of our original matrix. Then the sliding right is finished. We reach to the end of to the right of the original matrix. Then we start sliding it down, and then we again repeat the process where we multiply each element of the original array with the corresponding element in the kernel, and then we sum it. Sometimes we sum, sometimes we could average also. So depending on the nature of the operation that we want to do. So again we slide to the right, slide it to the right again. So finish the second pass. Then we slide to the bottom while sliding it down by one row, and again then slide to the right, and then again we slide to the bottom, and then we slide to the right. So we finish that operation by sliding the kernel on the original matrix starting from left to right and then from top to bottom. Okay, the final output will be a 3 by 3 matrix. Remember, our original matrix was 5 by 5. So when we convolve, and let me show you again. So this was the output for a single 3 by 3 part of our original matrix. So each 3 by 3 will be reduced to one cell. So 9 cells will be reduced to 1. So if you continue the operation and calculate the final output, what you will see is the final matrix will be size of 3 by 3. So convolution operation has reduced the size of our matrix from 5 by 5 to 3 by 3. Often we apply multiple kernels to original image. So after each kernel, if the size of the original matrix is getting reduced, we will have an issue of a diminishing matrix where the size of the original matrix will get reduced, and then finally we will have a very small image output which is not desirable. So to address this problem where size of the matrix is reduced after the convolution operation, what we do is, in order to prevent that from happening, what we do is something called padding. So whereby we increase the size of the original image by an amount in such a way that after padding, the size of the image will be same as original image. So here we have an original image whose size is 5 by 5, right? 5 rows and 5 columns. So before we apply convolution, what we do is we apply a padding to each row and column. Basically what we do by that, what we mean is we add a row to the top, row to the bottom, column to the left and column to the right, right? And then what we do is we just fill it with the nearby values. So for example, the top left we fill it with 100, top right we fill it with 1 because the nearest value is 1, top bottom we fill it with 67 because the nearest value is 67, and bottom left we fill it with the value of 13, and the remaining value we will just copy the edge rows to the corresponding blank rows that we just added. So we first increased the size of the 5 by 5 matrix to the 7 by 7 matrix, and then if we apply the convolution to the 7 by 7 matrix, the output will be 5 by 5 matrix, right? So which is the size of the original matrix. So this is how we use padding in order to preserve the original image size. So typically to calculate the new size which we need to apply before applying convolution, this is the formula we use. We use the original size, which is 5 by 5, the kernel which is 3 by 3, and minus 1. So 5 plus 3 8 minus 1 is, so 5 plus 3 8 minus 1 is 7, right? So this is the size of the matrix that we need to improve before we apply the convolution. This is the formula that is used. So always remember, we should use this formula of padding to increase the original size, so that after applying kernel, the size of the matrix gets reduced to the original image size, correct? So this is very important.